Hi, in this video, we are going to look at how we go about adding and subtracting fractions. Before we look at algebraic fractions, I'd like to go back to the very basics. In order to add or subtract fractions, they must have a common denominator. This means the denominators must be the same. To add or subtract, we keep the denominator the same and we focus on the numerators. Let's look at an example. Simplify the following. 1 over 3 plus 1 over 3. 3 is our denominator, so we know it'll stay the same. Then we add 1 plus 1, and we get 2. So our answer here is 2 over 3. We do the same thing when subtracting. 5 over 8 minus 3 over 8. So we know our denominator will be 8. 5 minus 3 is 2. Simplify by dividing 2 and 8 by 2. And we get an answer of 1 over 4. The idea also applies to algebraic fractions. X over a plus 2x over a. Our denominator is a, so we can put that in over here. X plus 2x gives an answer of 3x. But what happens when the denominators are not the same? We cannot add or subtract denominators, so what do? Let's make some more space over here. In lower grades, we learned that a multiple is the value you get when you multiply a number by different values. Let's look at the multiples of 2. 2 multiplied by 1 is 2, by 2 is 4, by 3 is 6, by 4 is 8, by 5 is 10, by 6 is 12, by 7 is 14. Now let's look at the multiples of 3. 3 multiplied by 1 is 3, by 2 is 6, by 3 is 9, by 4 is 12, by 5 is 15, by 6 is 18, and by 7 is 21. 6 and 12 are multiples of 2 and 3. So we say that they are common multiples. But 6 is the lowest multiple. So we say that is the lowest common multiple. We are going to use this idea when working with fractions. Here we have y over 2 plus y over 4. We've just seen that 4 is a multiple of 2. And we get to 4 by multiplying 2 by 2. So we're going to multiply this whole fraction by 2. And remember that when you do this, you have to multiply both the numerator and the denominator. So we're going to say 2 multiplied by y, and it will give us 2y. 2 multiplied by the denominator 2, and we get a denominator of 4. Now we can add y over 4. Our denominator is 4, so let's put this over here. Now we can add 2y plus y, and we get an answer of 3y. Let's do another example. Z over 7 minus z over 14. We know that 14 is a multiple of 7 if we multiply by 2. So let's multiply this whole fraction here by 2. 2 multiplied by z gives us 2z. 2 multiplied by 7 gives us a denominator of 14. And now we can subtract this fraction over here, z over 14. 2z minus z is z, so we get z over denominator of 14. Now, but in some cases, it is not as easy to find common multiples. Here we have 6 and 5. Let's find the multiples of 6. We have 6, 12, 18, 24, 30, 36, and 42. Now let's look at the multiples of 5. 5, 10, 15, 20, 25, 30, 35, and so on. 30 is the only common multiple of 5 and 6. So in cases like this, we need to multiply the numerator and the denominators together. So in this case, we're going to say 6 times 5, and we're going to get a denominator of 30. But to do this, to multiply this 6 by 5, we multiply this whole fraction by 5. 5 multiplied by 1 gives us 5, so we get 5 over 30. Then for the second fraction, we're going to multiply it by 6. So we multiply the whole fraction by 6. 6 multiplied by 1 is 6. So now we have 5 over 30 plus 6 over 30. Our denominator will be 30. 5 plus 6 gives us an answer of 11. We can also do this when we subtract. Here we have denominators of 3 and 8. To multiply them together, and we're going to get a denominator of 24. So let's multiply this fraction by 8. 8 times 2 gives us 16. 8 times 3 gives us 24. For this fraction, we're going to multiply by 3. 3 multiplied by 5 gives us 15. 3 multiplied by 8 gives us 24. Now we have a common denominator of 24. So our answer will have a denominator of 24. 16 minus 15 gives us 1. And our answer is now 1 over 24. The reason that this is so important is because it helps us with algebraic fractions. Here we have 1 over x plus 1 over y. No matter what you multiply x by, it will never become y. So we create a new denominator by multiplying these two together. X multiplied by y gives us x, y. Then remember, we multiply our first fraction by y. Y multiplied by 1 gives us y. And then we multiply our second fraction by x. X multiplied by 1 gives us x. Y and x are not like terms, so this is our final answer for this question. But please be very careful here. When working with algebraic fractions, we have to consider the coefficient of the variable separately from the variable itself. Here we have 3a and here we have 4a. Both denominators include a variable of a. So if we multiply by a, we get a squared. We don't want to do that. We need to consider the coefficients of these variables, which are 3 and 4. And they are the values that we multiply together. So in this case, 3 multiplied by 4 gives us a new denominator of 12a. To make 3a 12a, we multiply by 4. So we multiply this whole fraction by 4. 4 multiplied by 2 gives us 8 over 12a. For the second fraction, to get to 12a, we multiply it by 3. 5 times 3 gives us 15. So we get 15 over 12a. Now that we have a common denominator, we can add these two fractions together. 8 plus 15 gives us 23 over 12a. Let's do one more example. 3p over 5 plus 3p over 7 plus 3p over 10. Now our numerators are the same, but our denominators are not. So the first thing we need to do is we need to find a common denominator for all three values. 5 is half of 10. So every multiple of 10 is also a multiple of 5. So now we need to find a multiple of 10 that is also a multiple of 7. And to do this, we simply multiply these two values together. 7 multiplied by 10 gives us a denominator of 70. To make 5 70, we multiply it by 14, which means we have to multiply 3p by 14, and we get 42p. To make 7 70, we multiply it by 10. Let's multiply 3p by 10, and we get 30p. over 70. Finally, to make 1070, we multiply it by 7. So let's multiply this 3p over here by 7, and we get 21p over 70. We now have a common denominator of 70. So our answer will have a denominator of 70. Now let's add our numerators together. 42 plus 30 gives us 72, plus 21 gives us 93p. We cannot simplify this answer, which means that this is our final answer. You will see more examples like this in upcoming videos.